Hi there, let's calculate this integral using Fourier transform. And first, let's consider such rectangular pulse, evenly placed on the time axis. And by definition, its spectral density, or direct Fourier transform, is given by this expression. The limits of integration are replaced by minus t0 over 2 and plus t0 over 2. Exponential multiplier turns to cosine to its even part. And we have such integral a. Inside this interval we have this value of s from t multiplied by cosine from omega times t dt. A is a constant value. Integrating cosine, there will be a sine divided by omega and the same limits. Sine is odd function, so in order to calculate this, we simply take the value of this function in this limit and multiply it by 2. So 2 times a sine omega t0 over 2 divided by omega, and some additional manipulation. Let's multiply numerator and denominator by t0 over 2. Here will be a times t0 sine from this expression divided by this expression. And you may find that this fraction may be called sine c, or sinus cardinalis from omega times t0 over 2. Why have I done it? This is direct Fourier transform, and also there is an inverse Fourier transform. Inverse Fourier transform permits to calculate a signal knowing its spectral density. And it looks almost the same except of this multiplier, and by definition we may calculate the signal using its spectral density in such a way. I think it's already clear why have I done this manipulation. Because when I took this expression and put it inside this integral, I may get something looks very similar to this. Okay. Let's put it inside an integral. And now let t0 will be 2. A will be 0.5. Then t0 over 2 equals 1. And one more step. Let's calculate a signal value s from t at the moment t equals 0. And this value, according to this picture, is a, or 0.5. From the other hand, using this expression, we will have 1 over 2 times pi integral from minus to plus infinity a times t0 is 1. Then sine t0 over 2 is also 1. So sine from omega divided by omega. And if t equals 0, then this exponential multiplier turns to 1. D omega. And this is exactly what we need to calculate. So I equals, we put 2 pi to the left side, and we have 2 pi times 0.5. And finally, our integral equals pi. That's all, folks. Please subscribe. Thanks for watching. See you next time.